All right, this is 9.4, Graphing Linear Functions, Part 2. So let's go ahead and wrap up this part of Lesson 9.4, and really the last thing we're going to do in our notes. So graphing linear functions. All right, don't forget, what is a linear function? It's one where the graph is a line. How can you remember that? Just look at the word line right there in linear, right? The word line is right there in the word linear. Should be easy to remember. All right, so linear functions, the graph is a line. A there, every point of the line is another set of coordinates, x, y values that solve the equation. So remember, every point of the line is a set of x, y coordinates, the values that solve the equation. And so what did we do for the line given? I showed you 5 of the possible points. Oops, can't circle, right? 2, 3, 4, 5, and we figured out those values, right there. What did we do? We took the function, we put in the x value and figured out the y value, right? We put in the x value of 0, figured out the y to be -3. Put in the x value of 1, figured out the y to be 1. Put in the x value of 2, figured out the y value to be 1. Put in an x value of 3, figured out that the y value is 3. Put in an x value of 4, and we found that the y value is 5. Did all this yesterday. And so there's the graph of the line. Now remember, please remember, we're only showing 5 of the points on the line. The reason we draw a line and put arrows on both ends is every single point is the xy pair that makes the function true. That xy pair, that xy pair, that xy pair, that xy pair, this one, that one, this one, this one, this one. And remember, the line goes on forever, up and to the right toward positive infinity, and it goes on forever down and to the left towards negative infinity. And so always put arrowheads on your lines. What else did we talk about yesterday? We talked about verifying if a point is a solution. Is a point a solution? Or figuring out if the point is on a line. It means the same thing. Is the point a solution or is a point on the line? How do you do that? Substitute in the values, the coordinates. Sub in the x coordinate for x and the y coordinate for y. So here was our first point, 1, 4, negative 1, 4. We put in negative 1 for x. We put in 4 for y. So take a look. Here's negative 1 in for x. Here's the 4 in for the y. When we do that, we ended up with 4 equals 4, a true statement. If it is a true statement, remember now, that means the point is a solution to the equation. It also means the point is a point on the line that is the equation. In the second example, we graphed it. We substituted in, and we did not get a left side equaling a right side. Therefore, the point was not a solution. It was not a point on the line. Okay, and then we talked about a graph of a line. You must know at least 2 points. So geometry says any 2 points determine a line. But remember, if you only graph 2 points, it's possible to be wrong and you'll never know it. Instead, I said to you, hey, graph 3 points. Why 3 points? Because you'll know if they don't go in a line, then you know something's wrong. Take a look at the graph. If you get 1 point here and 1 point here and 1 point here, well, I got news for you. That's not a line. So you know something's wrong. Either the values you got for your points are wrong or the plotting of your points are wrong. One of the two. And you know it's got to be one of those two. And so go back and check your work. All right, so what did we do when we were going to graph y equals, so here's what we're graphing, right? Y equals negative 3x plus 5. That's what we're going to graph. Remember, you get to choose any value for x. You choose any value you want. What's the best value? 0. 0 is the best value to choose for x. You can choose anything else. We chose 0. When we put it into the function, we found the y value to be 5. When we did 1 and put it into the function, we found the y value to be 2. And when we chose 2 for the independent variable, the x value, oh, I didn't know I could do that. We found that the y value would be -1. Okay, we graphed the line. So that's where we're at. Let's go ahead and pick up from there. Let's do the next example. All right, B, graph f of x equals 2x plus 1. Now, right off the bat, remember functional notation. Don't let it scare you. It's like a language. The f of x is always just simply in place of the y. It's in the place of the y. So if you want to replace the f of x with a y, and there's really two ways you can do your xy chart. One in functional notation, and the other like example A, where we're finding the y value. So if you look at your xy chart, where y is, you could also have, if you want it, I shouldn't have used that first parentheses, where y is, you could also have f of x. Same thing. They're interchangeable. Okay? All right. Remember, how many points do we need to graph our line? And I hope you said 3, right? All right, what's the best value to use first? I hope you said 0. All right, to keep everybody on the same page, in class today, I asked them values, and somebody said 0, then somebody said 4, and I wrote the 4 down here, and then somebody said 1. So I want you to, Cole, I want you to go ahead and graph those values. So figure out, sub in the x and figure out the value of y, plot the first point. Sub in the value of 1 for x, figure out the y and plot that point. Sub in the value of 4 for x, figure out the y and plot that point, and then turn the video back on, okay? All right, so pause your video, go ahead and do that, and then turn it back on. Okay, so this is where you would have been. Y or f of x, 2 times x plus 1, 0 is always nice. 2 times 0 is 0. 0 plus 1 is 1. So your first point should have been 0, 1, and it should be graphed right there. Okay, great. Second point. This time we're putting a 1 in for the x. 2 times 1 is 2. 2 plus 1 is 3. And we get the point 1, 3. So the x is 1, we go to the right one, and the y is 3, we go up 3. And there's our second point. Hopefully you agree. Now look what happens on this third one. And hopefully you've been here already. You've done this already. Because one of the students today mentioned using a 4. And you can use any value. You know, I told the students today, you could use 100 if you want to. You can use any value. The only problem is if you use 100, you need a big piece of graph paper. All right? And watch what happens here with this 4. 2 times 4 is 8. 8 and 1 is 9. Okay. How do you plot the point 4, 9? When I go to the right 4, I can't go up 9. The graph doesn't go that high. What do I do? Say, oops, oh well, guess I can't do it. I'm done. No, we need 3 points. So you know what? Do another x value. And when I asked in class today, they came up with 2. Yeah, great choice. Let's use 2. And that was a good example of don't go so far down the road with your x values. Okay, so let's figure out the y value when the x value is a 2. 2 times 2 is 4. 4 and 1 is 5. Agreed? Let me give you a second to catch up. Again, don't forget you can pause any moment. All right, plot the point 2, 5. 2 to the right, 5 up. Are all 3 points in a line? Yes, they are. Draw a line through them, put an arrow on both ends. And by the way, notice what I did. Notice that my line is pretty large, right? It fills the graph. I saw some students' homework papers earlier today, and their lines were just these little itty-bitty lines in the graph. You know what? Fill the graph. Draw the line. Let it fill up the graph like mine does, right? Fills up the graph. Okay, one more. Last question here. All right, so look at C. Now C's got something that's unique. And that's what we've got to do is we've got to look at the x term. Notice the multiplier of the x is a fraction, right? You see it right there? Oh, what in the world did I do? I have no idea. All right, you got that fraction there, the 3/2. That's ugly. Let's get rid of that. Okay, so you've got a 3/2, and it's a 3/2 x. Well, remember with a fraction, when we go and do, here, let me do it this way. Let's suppose we're going to do our first number, right? Remember, it's 3/2 times x minus 3. Now, the first number and the best number to always use is what? 0. All right. Well, 0 is easy because 0 gets rid of the fraction, doesn't it? Anything times 0 is 0. All right. So 3/2 times 0 is 0. 0 minus 3 is a negative 3. All right. Our first point is 0, negative 3. All right. Don't go anywhere left to right on the x-axis because it's 0, but go down 3. So your first point is right there. Now, before I put the second point in, let me again show you where we're at. Here's where we're at. Notice this 2 on the bottom. Now I can use any value I want. If I use 1, I can use 1, but you know what? I'm going to get fractions. And students tend to want to avoid fractions. Well, here's the point. If I use a value for x that can be divided by the 2, I won't have any fractions. All right, so here's the point. Instead of doing 1 next, I'm going to use 2. And I can use 2 in the blank. All right, do you remember RBUM? Reduce before you multiply. What's 2 divided by 2? That's a 1, and they divide out, don't they? So now we end up with 3 minus 3, and that's a 0. And we've got the 0.20. See, we've avoided fractions. Now you can deal with them, but it's just easier not dealing with them. So where's the 0.20? Go 2 on the x-axis and don't go up or down at all. We got a point right there. We need a third point. Okay. Most students then, when I asked, said, let's use 4. Again, something that you can divide by 2. So again, I'm setting it up right. Y equals 3/2 parentheses. And then minus 3. And in the parentheses, I'm going to put my x value, my independent variable value, my domain value. And again, I'm going to RBUM, reduce before I multiply. And so that's a 2. Remember now, you're multiplying. 3 times 2 is 6. 6 minus 3 is 3, and you get the 0.43. 4 to the right and 3 up. All right, that's the third point. Now, by the way, some other values you could have used. You can use -2. That's fine. -4. Anything divisible by 2 by the denominator. So just aside for a second here, just to get you to think for a second of other possibilities. Let's suppose you had a function. I'm going to go right under the graph. Let's suppose you had y equals 1/5 x minus 2. All right, you got a 1/5. Whoa. My magic pen is being very magical. 1/5 x minus 2. What do you want to use for that x? Hey, use a 5 or a 10 or a 15 or a -5 or -10, right? As you can see, my magic pen erases. All right, anyhow. Let's go ahead and finish up by drawing our lines. So I'm going to take my red. I'm going to draw through again. Notice how I try to fill up my graph where the line is. Arrowheads on both ends. And there's two more terms we have to talk about that are important terms. All right, I want you to look at the line, and I want you to look at where the line crosses the y-axis. Okay, this is called the y-intercept. The y-intercept. It's the point where the line crosses the y-axis. Remember, the vertical axis is the y-axis, right? And so that's the y-intercept. Now, what are the coordinates of the y-intercept? The x-coordinate is 0. And for this y-intercept, the y-coordinate is -3. Now look, this is a key concept. Notice we really found the y-intercept when we use 0 for the x value. Anytime you use an x value of 0, you find the y-intercept. You might say, why is that, Mr. Scarf? I don't understand that. All right, let me show you some lines. I want you to tell me the x-coordinate of the point where the line crosses the y-axis, the y-intercept. Watch. So what is the x-coordinate of that point right there? 0, right? And the y is 4. Every y-intercept has an x value of 0. What if the line's here? What's the x-coordinate of that point? 0, right? It is 0. What if the line goes like this? All right, let's make believe that's at 1. All right, what's the y-coordinate? 0. You know what? I don't even have to hit a good x point. Doesn't matter. Good x, y point. Doesn't matter. What's the x-coordinate of that point? 0. What's the x-coordinate of that y-intercept? 0. The x-coordinate of that y-intercept? 0. The x-coordinate of that y-intercept? 0. That y-intercept? 0. That y-intercept? 0. Here's the point. The x-coordinate of every y-intercept is 0. All right, there's one other point of interest, and that's this point right there. So if the other one was the x-intercept, I just gave it away, it's the y-intercept. This one must be the x-intercept. And it's right there. Now the x-intercept has coordinates of what? Well, this one, the x value is 2, and the y value is what? 0. And guess what? The y value of every x-intercept is 0. The y value of every x-intercept is 0. So watch again, watch the graph. You tell me the coordinate, the y-coordinate of the x-intercept. What's the y-coordinate of that point? 0. 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 What's the y-coordinate of every x-intercept? 0. And you know what? For that reason, sometimes we don't even call them the x-intercept. We call them a 0. A 0 or the x-intercept. You say, Mr. Scarfy, why would we call it 0? Why didn't we call the y-intercept a 0? Watch now. Remember, the x-coordinate is the domain, the input, and the y is the range, the output. What's the output of every x-intercept? 0. You get a 0 output. 0 output, 0 output, 0 output. That's why we call it a 0. All right. That's the lesson. Graphing linears. When you get to Algebra 1, we'll teach you a nice handy-dandy way called slope-intercept form. But for right now, we're going to graph them using an XY chart. And here's the beauty of an XY chart. And that's what we did right over here, right? This was an XY chart. You can graph anything using an XY chart. All right, that's the lesson. I did assign the homework to the class tonight, and they're going to take a quiz tomorrow, and then we are going to review for the final exam from there. All right, have a great night.